For decades, scientists believed modern humans evolved with fragile, slender, gracile ribcages, distinct from our Neanderthal cousins. When Ötzi emerged from the ice, his chest seemed to confirm that story. But a groundbreaking digital reconstruction has just revealed evidence that changes everything we thought about our evolution. If our own ancestors sometimes rivaled Neanderthals in physical form, what else have our bones concealed? At the edge of a melting glacier, a man once climbed through the high passes of the Tyrolean Alps. His world demanded resourcefulness at every turn. Survival here meant bracing against sudden storms, thin air, and the constant threat of cold. The clothing he wore was a testament to this life. Layers of goat and deer hide stitched together, grass fibers woven for insulation, and a fur cap pulled tight against the wind. Each garment served a purpose, trapping warmth during freezing nights and shedding moisture during long climbs. Strapped across his back, a copper axe caught the light. The metal, traced through isotope analysis to Tuscany, had traveled hundreds of kilometers before reaching his hand. Copper tools were rare and valuable, signaling both status and the reach of trade networks across prehistoric Europe. The axe's polished blade and sturdy U-handle spoke of skill and care, not just in its making, but in its daily use. Cutting wood, shaping shelters, perhaps even defending against wild animals or rivals. His skin bore a different kind of record. 61 tattoos, dark lines and dots etched with soot, marked his joints, spine, and legs. Far from decoration, their placement matches areas prone to pain or strain. Researchers believe these were early forms of therapy, a prehistoric attempt to ease aching muscles and overworked limbs. Each tattoo hints at a body pushed to its limits year after year. Even his final meal reveals a life shaped by movement and adaptation. In his stomach, scientists found traces of ibex meat, lean, wild, and tough, paired with einkorn wheat, one of the oldest cultivated grains. This mix of high-protein mountain game and domesticated plants points to a man whose days were spent traversing steep slopes, hunting, gathering, and trading between valleys and uplands. Every artifact and bone fragment tells the same story. Ötzi was no passive wanderer. He was a practitioner of alpine survival, his body and belongings shaped by a landscape that demanded endurance, ingenuity, and relentless effort. The strain of this existence left its imprint deep within, setting the stage for the hidden secrets that his ribcage would later reveal. The end came violently. An arrowhead buried deep beneath Ötzi's left collarbone sliced through nerves and blood vessels. He collapsed face down, and his body quickly locked in ice. In death, the mountain preserved what time would have erased. Flesh, clothing, and bone sealed away for 5,000 years. But the glacier's embrace came at a cost. The weight of centuries pressed Ötzi's chest flat, bending and warping his ribs out of shape. For decades, this distortion hid the true form of his ribcage, leaving only partial answers to the questions his bones might hold. Enter José M. López-Rey and his team at the National Museum of Natural Sciences in Madrid. Their challenge was to recover what violence and ice had twisted without disturbing the fragile remains. The solution lay in technology. Using high-resolution computed tomography scans, they captured every fragment of Ötzi's thorax, vertebrae, ribs, sternum, down to fractions of a millimeter. Each bone became a digital mesh, ready for analysis. The next step required precision. In specialized software, the team placed 526 landmarks and semi-landmarks on the virtual ribcage, points that trace the curves, angles, and edges of the thoracic skeleton. These digital coordinates allowed them to correct for postmortem bending, restoring the original three-dimensional shape. The process, called geometric morphometrics, let them compare Ötzi's chest not only to other ancient humans, but also to Neanderthals and Homo erectus. This was not a solitary effort. Alongside Ötzi, the team reconstructed ribcages from 3 other prehistoric Homo sapiens: Nazlet-Kadar II from Egypt, Ohalos II H2 from Israel, and Dolny Vistonich 13 from the Czech Republic. Each specimen, scanned and landmarked, formed a virtual archive of ancient human chests. For the first time, researchers could measure and compare thoracic proportions across 30,000 years of our species' history. Their findings, published in Communications Biology, would soon challenge what everyone thought they knew about the human body. Across 3 continents and nearly 30,000 years, the digital reconstructions revealed a clear pattern. Each ancient ribcage told a story about the world it grew up in, a story written in bone and shaped by climate. In the warm, humid Nile Valley, Nazlet-Kadar II developed a chest that was narrow and cylindrical. This shape, with its smaller volume, would have helped shed excess heat, a natural adaptation for life in a hot environment where overheating posed a greater threat than cold. The same pattern appeared in O. Hollow II, whose remains surfaced near the ancient shores of the Sea of Galilee. Her ribcage echoed the slender, heat-dissipating form seen in Nazlet Khater II, reflecting a temperate but still relatively warm climate. Both individuals, separated by thousands of years and hundreds of miles, shared the same basic thoracic architecture, compact, efficient, and built for cooling. Ötzi, preserved high in the Alps, did not fit neatly at either extreme. His ribcage was neither as narrow as those found in the warmest regions, nor as broad as those suited for the coldest. Instead, his thorax blended features, a slightly larger, more rounded chest than Nazlet or Ohallo, but not the full barrel shape seen in cold-adapted populations. This intermediate form matched his unique lifestyle, constant movement between temperate valleys and freezing mountain passes, a life that demanded both heat retention and the ability to cool off during strenuous climbs. The spectrum was clear. From the Nile to the Alps, ribcage size tracked the temperature gradient, shrinking in the heat and expanding in the cold. The logic of adaptation seemed orderly and predictable, each fossil a witness to the climate it endured. Dolny Vestonis 13 stood apart from every pattern that seemed to make sense. His ribcage, digitally restored from Ice Age bones unearthed on the frozen plains of what is now the Czech Republic, was not just broad. It was nearly the size of a Neanderthal's. The measurements left little room for doubt. In both overall volume and chest width, this young man's thorax rivaled the so-called barrel-chested Neanderthals, those icons of cold adaptation. Yet Dolny Vestonis 13 was a Homo sapiens, living 30,000 years ago, long after Neanderthals had vanished from these lands. The numbers told the story. When researchers compared his ribcage to the classic Neanderthal specimens, Kabara II and Shanidar III, they found Dolny Vestonis 13's chest almost matched them in size. But there was another twist. His ribcage was actually broader, relative to his body, than that of Homo erectus, a species that had survived for over 1 million years in Africa and Eurasia. For decades, textbooks had drawn a clean line. Neanderthals and Homo erectus were robust, built for cold and hardship, while modern humans were supposedly slender and gracile, an evolutionary shift toward efficiency and mobility. Dolny Vestonis 13 shattered that line. His bones proved that our own species could grow just as stocky and broad-chested under the right conditions. This discovery forced scientists to reconsider what it means to be human. The old dichotomy, gracile moderns versus robust archaics, collapsed under the weight of Dolny Vestonis 13's chest. Here was a Homo sapiens, whose body adapted to the brutal cold of the last glacial maximum, developing a thorax that could trap heat and fuel the lungs for high-energy hunting on the periglacial steppe. The study, published in Communications Biology, confirmed that human anatomy is not fixed but plastic, shaped by the push and pull of climate and survival. Dolny Vestonis 13 stands as a reminder. The potential for both slender and stocky forms has always been hidden within us, waiting for the world to call it forth. Today, science reveals that our bodies still echo ancient adaptations, shaped not by a single path, but by climate, movement, and survival. Human evolution is not fixed. It is ongoing, written in every one of us. The real story of who we are is only just beginning. What do you think?